In this simulation, you were figuring out how to balance equations. And the simulation restricted you to changing only the coefficients in the reaction, the numbers in front of the chemical formulas. And in doing so, you were only allowed to change that. And if you changed the subscripts, you would have changed the formulas, and that would have changed what we were working with. It would no longer have been nitrogen plus hydrogen produces ammonia. And so your goal here was to make sure you had the same number of each type of atom on each side of the equation. And so if we have one of each of the reactants and one of the products, we're not balanced, right? We have two blue spheres on the left, which represents nitrogen, and one blue sphere on the right, and then two white spheres on the left and three white spheres on the right, which represent hydrogen. So if we put a 2 in front of the NH3, that balanced out the ends, right? The same number of blue spheres on each side, but it further messed up the H's, right? It's way out of balance. There's more H's on the product side than there are on the reactant side. And so if we adjust the coefficient in front of the H2, that begins to bring it more into balance. But 2 H2s isn't enough, but 3 H2s gave you plenty of hydrogen to balance it out. So 6 hydrogen on each side, 2 nitrogen on each side, and that equation is balanced. The next one that you went to was separating water. And we'll start again by putting a coefficient of 1 in front of each of the reactants. And again, you cannot change the subscripts, right? H2O has to remain H2O. If I change any of the subscripts, then it's no longer a molecule that represents water. And this reaction is the decomposition of water, right? Breaking it into its pieces and creating hydrogen gas and oxygen gas. So if we start with one of each, we see that the hydrogen atoms are balanced, but the oxygen atoms aren't balanced. So we're going to need to start by adjusting the amount of oxygen. Well, the only way to add more oxygen on the left side is to put a coefficient of 2 in front of the water. And so if we do that, you'll see that it will fix the oxygen, but it's going to mess up the balancing of the hydrogen. And so the oxygen is now balanced with 2 on each side. But now the hydrogen is no longer balanced. There are 4 on the left side, and there are 2 on the right side. So what can we adjust now to make sure that the hydrogen is balanced? Well, if we look at the product side, which is where we need more hydrogen, if we change that coefficient to 2, then all of the atoms are balanced, right? To balance an equation, you need the same type of each atom on each side of the equation. And so that is the law of conservation of mass, right? The mass of the reactants needs to equal the mass of the products. And we make sure of that by balancing the equation, right? It's taking that equation from the shopping list to the recipe. So then you looked at this one, the combustion of methane, CH4 plus O2, producing CO2 and H2O. And again, with this one, we'll start with coefficients of 1 in front of every molecule. And when we do that, nothing really is in balance. The carbon is in balance, and that's about it. So let's start with the hydrogen. And I want to start with the hydrogen because oxygen appears in one place on the left and 2 places on the right. And I want to start with the simplest scenario. So if I adjust the hydrogen and make 2 water molecules, then I've got the hydrogen balanced. But now the oxygen is out of balance, right? There's not enough oxygen represented on the reactant side, and there are 4 oxygen on the product side. So if I adjust the coefficient in front of the oxygen, in front of the O2 on the reactant side, I can balance this equation. If I make that a 2 in front of the oxygen, then this equation is balanced. So again, this is obeying the law of conservation of mass. There are the same number of each type of atom on each side of the equation. one carbon on each side, 4 hydrogens on each side, and 4 oxygen atoms on each side.